Now, everything we're doing today you've seen in geometry. One difference is now we're all mature, we've grown up, so we can now use SSA or ASS. I'm going to show you how we're going to do that. That was the, you can use side before, side, angle, side, angle, angle, side, angle, side, angle, and hypotenuse side. Now you can use SSA, and you can do that backwards if you really want. Did you make it to homeroom this morning?
I was late.
Okay, they just marked you absent, and I didn't see a sign in, so I wanted to check.
Oh,
Just, oh, no, you didn't have to get a pass though, right?
no.
Just let them know that you were here.
Okay.
Whoever. Not really too much new here. This is what you guys have been doing since chapter 3 or 4 in geometry years ago. It's just saying make sure you understand the relationship between capital A, lowercase a. Your capital letters are going to represent angles from now on, or they have been for 2 years. And your lowercase are going to be your side lengths that are opposite of their respective letters. See a couple people still writing, so I'll give you a minute. Well, have you copied everything?
Yeah.
Dan, talk to you a little bit about what we're going to do. I'll pull you out there.
He's recording. Ooh, hello there. Just take the pencil. Right to the camera. Oh.
What am I going to do on there? What's that like? It was your. I gotta cut all this out so it's. Alright, everybody still working on copying this part? Alright. So we're just moving on. We completely skipped chapter 5. No, we just took the test on chapter 5. We'll finish the test tomorrow.
I have to do this next day.
Yes, sir. When?
Today, right? You said?
What block are you gonna come in?
Oh.
Why don't you just get next block for research?
So what we'll do, you're gonna start the test on Friday. You're gonna take the topic 6 test on Tuesday. And then whatever time you have left, you're gonna take the rest of the topic 5 test.
Well, I can do it during research block.
When's research block?
Next block.
I'm not here next week. I'm just kidding. I'm here, but can we do it on Tuesday? We'll start it Friday, finish it Tuesday.
Okay.
I already have a meeting for the next block, so I can't leave you alone. And it's too short notice, I have to let a teacher say. So
Okay.
Friday, you start it Tuesday. So that
Okay.
we same amount of time there.
Thank you.
You are welcome. Which means you don't have a topic 6 review, right?
No, I don't.
Perfect. Once this is done, I'll make it out.
Thank you.
So, this whole chapter, we're not doing anything with right angles anymore. There's no right triangle. When you don't have a right triangle, it's called an oblique triangle. We talked about all of that, what it means to be oblique and stuff in topic 11. geometry, which was the original lockdown. I know that we all saw it, so we'll do a little bit of looking at it before we move on. This right here is not something I told you in geometry, but those four rules, or those four setups, those four conditions, with this in the paragraph letter, it tell you exactly what to use. There's no more, in geometry I made you look at it and analyze, is this gonna be better for the law of sines or the law of cosines? Now I'm just telling you straightforward, if you have angle, side, angle, or that word we could never use before, SSA, you're going to use the law of sines every time. If you have side, or side, angle, side, you're going straight to the law of cosines. So I'll give you a minute to copy that down. You use the law of sines when you have more angles and sides known, or you have a bad word. And you use the law of cosines when you have a majority of your sides known. The next slide, we're just going to copy the law of sines. Then I'm going to show you an alternate way to write it. And then I'm going to show you the way that I use it. And then we'll practice one. Then we'll go to the law of cosine. There's three versions of the law of cosines. We don't want to have to memorize all three. So to make it easier, I'm going to give you a fourth one. But if you just use the fourth one, you'll never need the other ones. And then we'll be on to the review. So please keep the reviews up until after the lesson. Before I block the screen or the board from I mean, is there a marker on your desk or when you use this? Anybody have a black marker on their desk when they came in?
Maybe.
Oh. That one was running extra smooth this morning, so. This is when we get to the law of cosine. Or sine, sorry. Should make absolutely no sense, but I will tell you what it is. Or how it works once we get there. The law of sines has a triple proportion. It has sine of A, sine of B over B, sine of C over C. And for one, I don't even want to use all three of those. I'd like to get rid of sine of C over C right off the bat. And then to further simplify it, when we get to it, we're gonna set it up the same way every time, and it will be a much more efficient process. Let's see. Everybody down with this one? Alright, so, this is your law of sine. We're gonna copy it this way. I'm gonna show you an alternate representation of it in just a few minutes. I give people a chance to kind of copy most of this. Then we're going to talk about, I don't want to quite call it the simple method because it's just the simplification of it for the way we're going to be using it in this class. But I'll show you what that means and why I think it's a little bit easier to show mastery of this topic if we can see that this works. Is this looking familiar to anybody from geometry?
I don't remember geometry.
That's great. Who's your teacher?
I took it online. Here, that's why I don't remember.
Usually when I ask that question, I think you're in. I really just close the whole thing. I put my hand on my back. All right, let me get back up. Is it out of focus?
No.
Is it recording? So why do I have 3 producers behind you?
Troubleshooting again.
Alright, sorry about that. All the time I accidentally bumped that button. That's by far the worst. Mo, did you sign the waivers here on the YouTube channel?
I signed it.
Thank goodness, 'cause I really don't want to edit out that wave.
Wait,
Mo, you're gonna be on our YouTube channel, so the sun swallows you, about 45 years or so.
Say Mark. Yeah. That's a courtesy of Gavin.
The bars on this, because my handwriting is indistinguishable between capital and lowercase for C, so that means this is supposed to be taller than this one, because there's no special math or anything behind that. It's just so we know when I'm talking about capital versus lowercase c. So law of sine is a proportion with three separate terms. So if I reciprocate one term, then I reciprocate the second term, and I reciprocate the third term, I'm still going to have the same proportion. So we can rewrite it that way. And textbooks generally go back and forth on the way they do it, so we might as well see that. And we'll talk a little bit more about the properties of proportions once I see everyone's done copying it down. And then we'll solve one of these. Why are you graphing circles for physics?
It's not graphic circle, it's a formula.
Okay, why are you trying to track where a particle is on the circle? What does it do?
What are we doing?
What does that formula do?
Ah.
It's going to be 1 point because you calculate an infinite number of points and you're going to want to graph at the same time. What shape would you do? Josh?
Why is sine angle and bigger?
Because I've told you for years straight, in geometry, you can never use that. It's just not valid, don't do it. Now it is valid and it's fine. So it's just a reminder that that is now okay. Just go against everything I told you that year.
And why would be considered like the hypothesis? Would A be considered?
So that's the great thing. So here, these dotted lines are not actually part of the triangle that we're looking at. These are, when you see this word oblique, that just means it has no right angles. It can be an acute or an obtuse, but there's no 90-degree angle there. We're doing this, so if I ask you to find the area of this triangle, we know that that's 1/2 base times height, right? Where in the world is the height in this thing? We drop an altitude. We drop another altitude so they meet perpendicularly. This is now the height. We're only using this to show that these are two altitudes meeting, so we have the height of the triangle. This is not important right now. This is going to be important when I actually find the area, but for the law of sines, we only worry about the oblique triangle or this solid line triangle. So that's a good question. Now, everyone done copying all this down? So before I move on, these are the 3 times I can use the law of sine. No, it's not. Never do it from memory. Alright. So if I have one of those 3 conditions, we can use law of sine. So let's look at. Let's look at this one. And let's talk about how. Let me see my sentence and then you go. In the past, whenever we use this, didn't we always have 2 triangles? And we were trying to prove their congruence. Right, that's what this was originally for. Now, these are going to be the criteria to determine law of sines versus law of cosines in an oblique triangle. On your roof, what's up?
So you put the SAS up there for law of sines. Does that mean that SAS is for both law of cosines and sines?
Should it not be?
I think it's with and sin.
Oh, it's overwhelming angles, you're right. Double check.
Because that's what it said on the first slide.
Yeah, you're right. And I even said make sure your law of sines always has more angles than sides unless it's a bad word. Thank you guys. Now, Who remembers how to find if it's side, 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 angle, side, angle, angle, side, angle, side? What do we do? This was the first time in geometry, I think a lot of people started getting frustrated. Because you had to think about rigid motion transformations that would map one triangle onto the other to use these criteria. Great news, it doesn't matter this time. The only thing you need to know is never start with the included angle or the included side. Now that's a long back, way back vocabulary. What does it mean to be an included angle?
It's the middle one.
It's the one between the two sides that form it. So, this here, 102.3, is the included angle of those two sides. Here, this is the included angle of these two sides. What I'm saying is don't start on an included angle where you have your information that you know is on opposite sides of it. So this is not the angle you want to start with to figure out which one of these you want to do. You either want to start with this angle and see if you have a side, which you don't, right? It goes, your pattern's always going to be check angle, side, angle, side, angle, side. And you always have to have something, some bit of information within two moves. So let me show you what I mean. Tony, do you want to start with the angle or the side?
Angle.
Angle, perfect. So I'm not going to start here because this is an included angle between this node and this node. Well, this side. So I start here and I have an angle. If I go from the angle, the next thing I have is a side and I don't know what it is. So that does not help me decide. But within my next move, I have an angle. So that's good. If I did not know that angle, we could not use angle, angle, side, or anything that goes in that direction, and we would turn this way. And let me show you what it would look like if I did turn that way. I start here, I have my angle. Do I know this side? And Maddie, do I know this angle? No. I've got two X's in a row. I can't do this. Now, this is really how I would show it in geometry, to show kind of where my corresponding parts would be. But here, my next move is a side, and what congruence, or what measure do I have here? Do I have side, side, angle, 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 side, or angle, side, angle? Well, I went from angle to side, so I can use the law of sine for this one. This is just a quick geometry throwback because sometimes it's good to see it. All right. Now, here is my method. I want a known angle and its opposite side. Is there a condition on this triangle right now where I know an angle and its opposite side? Sam, where is it?
28.7 and then what's angle?
That's the angle, yes sir. And what's the side opposite of it that I know? So I'm going to put that on my left-hand side. Sam said sine of 28.7. That's a capital A, so I'm going to put my angle in there. And I'm going to put that over its known opposite side. So if you set this up this way, we have our known angle and its known opposite side, and we're good to go on the right-hand side. I like it this way because I'm going to have my variable will always be on the right-hand side, and I can kind of start seeing where everything's going to fall when I do enough of these. Sydney, go ahead. Say that one more time.
Because when I wrote it down, it says that the angle is above the size of the theater.
You have it this way. I did say that it comes up both ways in the books. And Sydney, this is a proportion, right? That means that whatever this ratio is equal to this ratio is equal to this ratio, right? If I reciprocate each of these, won't I end up with the same rule? This is just how I was taught. This is how I've always seen it. This book and your geometry textbook are the first time I've ever seen it this way. And then I looked it up to see if that was something new. Apparently this was the way that they traditionally did it. I just grew up in a weird time. Or like that, but they're the same. So that's really the only reason. It's just preference. You guys are welcome to do it either way. You're not going to do it much wrong. Now, Sam, you answered my last question, pick somebody for, was it Sam? No, it was Maddie. Who, I don't know, who was it?
Yes.
Maddie, pick somebody.
Callie.
I'm gonna let her stop staring me down like that before I ask her. Jeez. Callie, I need to know on this, I either need a known angle and a side that's opposite of it that's unknown, or I need an unknown angle and its known opposite side. I've already used 27.4. Do I know any other side lengths? So I know right now I'm gonna have to use opposite side. So, what angle do I know? So this is gonna be sine 102.3 over, jeez. Well, 102.3 is at angle C, and opposite of that is C, so I'm gonna do that. And that's how we set these up.
Wait, so is it a proportion?
This is a proportion.
So
Now-
just like, maybe across.
That is it, yep. Thank you for not saying the butterfly method.
I was about to say.
I know you were, I saw it in your eyes, and you looked at me, he's not gonna like that. And then, that's why I did this, so you could just say cross multiply. Now I'm gonna ask this question, because I kind of predicted coming up. What happened to sine C over C?
You said what?
This is a 3-part proportion. I told you to only make a 2-part proportion. Why don't we have that 3rd part?
You have to find the organ.
You're gonna have to find both, so don't complicate it with a 3rd piece. Go ahead and solve this one. Set it up again, solve it again. And if you do it this way, you already know what the left-hand side has to be. And you can find the right side really quick. Josh?
They all equal each other, why can't you just in your calculator put sine of 28.7 over 27.4? And that's your answer.
Because, look, that's what, you're saying go ahead and approximate this side, right?
Yeah.
Then how would I, then I would have, well, yeah, I'm going to do that. Then what would you divide by? How would you get C by itself? Like you have this side done, what would you do here? Well, this is sine over something, right? So then you would just take this side and divide it by sine, which we're gonna do, but I'm gonna show you all the steps. You're absolutely right, on track of what we're doing. You're just skipping a few steps, which makes it look so much harder. So, to cross multiply, we have C times sine 28.7. And that's gonna be 27.4 times sine 102.3. And then Josh, this is exactly what you said. Why not just go ahead and do this, right? And at this point, if you guys see what's coming like Josh did, go for it. If I at least see this part, I see the math, enough of it. You've convinced me here, Josh, that if you get to here, I'm fine with that. I've been very new work. I know you know what's going on. I personally will always go the full way. That's what's going in your calculator.
Oh, yeah.
And that's what you're gonna do to find your opposite side. Now, here comes the hard part. Which calculator are you guys using? If you have, may I borrow yours? If you have this one, the TI 84 plus CE Pipeline Edition, it's gonna look exactly like what I have on board. It even makes the or it even makes the fraction, it looks and represents it exactly as we had it. And borrow yours. If you have the TI 84 plus, it's not gonna look exactly like what's on the board. You're going to have to write this horizontally. So, let's talk about how we would put that in this calculator. Then we're gonna talk about the 30xa. Is this one yours, again?
Yeah.
Is that one? Oh, no, yours is that. Is that yours, sir? Can I borrow it? Oh, it's the one from my desk. I'll give it back to you after. But I'm gonna, so, if you're using the TI 84, 83, we're gonna put this in as 27.4 times sine. Oh, we already messed up. Start with a parenthesis. Let me write it out. That helps. parentheses. What line am I on? Wrong calculator. Let me double check that I wrote this, that's all right, 27.4 times 102. Cool. All right. Henry, what'd you get on your calculator?
55.7.
If you're using one of the TIs, 84, any addition, who has an answer on their screen right now for this? Whose answer starts with a 5? Whose answer is followed up by a 5? Then it's 0.7? So this is 55.7 for side. Before I commit to that, does this answer of a side length AB or just side C being 55.7 make sense? Well, if 28.7 degrees makes 27.4, this is substantially larger, and 55 is substantially larger, so that's a pretty good sign that we're good. Now, let's talk about if you're using the 30XA, what we'll do. Let me actually go out and you already got it? Thank you. Alright, so, on this one, let's go to a different color. You're on this 30XA. We're gonna punch in 27.4. Oh, you can't see one. And I'm gonna hit times 102.3 sine. And I'm gonna hit equals. And then I'm gonna hit divided by. And you also get 55.7. Now, I'm kind of falling back to when I taught this in the geometry classes for the last 4 years. Is everyone pretty much okay with using their calculator at this point? I know you have much more practice with it at this point, doing this 2 years ago.
The only thing kind of confused about with the calculator is when we're supposed to switch it.
To the inverse?
You
Or
know,
the green
inverse the ratings, like the settings.
Okay,
When are we supposed to switch it?
easiest way to know. Going forward, if you see this guy right here, that should appear to be in degrees. If you don't see it, I was talking to Mr. Ding about this yesterday. If you don't see it, it's technically at this point in radians. But in my class, anytime you see something in this form, you want to be in radians. It can be 3 pi halves. It doesn't matter. If there's a pi in it, be in radians. If you see this symbol, you're in degrees. I will not ever do this to you. Right? Because technically then you're in degrees, but that's just a horrible thing to do to you. So that's how you know it's other different.
Why did you put sine 28.7 as like the denominator for both? Like, how did you decide that?
on this step here.
On both of them, yeah.
Oh, here? This is just me showing it as independent division on opposite sides. I had my variable that I'm solving for times this, so I divided both sides by isolating my variable. What you're used to
okay.
seeing is this one, and I totally understand why it's a solution.
Oh, so you, okay.
But I don't wanna overheat any brains right now, so I showed it like the most elementary way. It's the same thing, I just broke it up there. Alright. Here's the question I thought you guys were gonna ask. How in the world do we find angle A? That's a good question. I know it's a question. Sydney, go ahead.
Well, if I don't know the inside of a triangle of 180 degrees, so can you just subtract the 180 by 102.3 gets out?
What do you guys think?
Yes,
I would only do
I
that
approve.
soon as well.
And you have proof?
Smart.
Smart.
Show me your proof.
Okay. You're showing the proof on it.
There's that.
49.
I mean, I don't have any proof,
So,
but
49.
I will say this. Be careful. On your review for topic 5, if you did that, would you have been losing a couple points? Right, a couple of those did not exist. What if this triangle didn't quite close? What if it just slightly overlapped, making it not a polygon? What if I did all of this just to show you a collection of line segments that don't quite close? So, Sydney, what would this be if we did 180 minus this minus this? This is what I'm gonna say. How would we verify that? Say again? Love to hear that. Yes, that is it. You're gonna use, that's the question I thought you were gonna ask too, when I kind of talked over you, so I'm sorry for that. So, we're gonna do the same thing. We're gonna set this up again, but this time we're looking for angle A. So this can't be on my known side. So on the left-hand side, what should my proportion look like? What should my left side? Remember, I have left here, right here. And this is why I like this method. Once I set it up the first time, it's always gonna look the same on the left. Sydney, what would you have on the left?
How would you do the sine 28.7
Over what?
27.4?
Yes, I kept seeing on 24.7. That's why I don't know what's going on. I'm making quite a few numbers here. Now, what did you have last time you started this problem? Same thing, right on the left-hand side? Now, we're looking for an angle. Do we know what this side length is? So can we jump straight to doing this yet?
No.
How would we find that side length?
Create another proportion. Or using
Using A this time, right?
as a variable, yeah.
Here's the dangerous part. This is technically unknown. This is what we're trying to verify.
So we use that.
Well, that's what we're verifying, right? We would need to know what this is to verify it using that. This is kind of like when the bank calls because you're getting fraudulent charges.
No.
What is there to say no to about that?
Yeah.
I'm gonna let that one go. Never mind. This is like if I knew your lunch number and you had an account downstairs, and I punched in your number and I charged like $10 in pizza, and then Coach Maggie was like, "Are you Kaylee Dallas?" And I was like, "I got her student ID. That's me." And she let it go. She verified it, but is she verifying good information? You and I can't pull up your student ID. You couldn't pull up my driver's license. That's what we're doing there. We're using something that's not quite proven yet. So that's not gonna work for us. I see Sydney's gears turning. I can see that you're thinking about this. I'll give it about 2 minutes. Really think about what we would have to do here to find if that is truly 49 degrees.
Hypothetical doing the chapter answer that you read.
That you have to do it 2 more times that way. Now, I will say this. Technically, we have angle, sine, angle here. This angle, we found this opposite side, didn't we? What was it, 55.7?
55.7.
So, let's just call it 7. So, why don't we just, and don't shoot the messenger on this one, but let's use that rounded version right there just to see, right? And if this comes out to be 49.01 or 48.999, we can probably say by the rounding, we got a slight deviation of 49. So we can say, yeah, it's close enough, we'll assume it's true for now. Or we can reuse, what was the trig that we had to do here? It was like sine of, what did this end up being again? Mo, are you paying attention? That's the stuff I want, right? Or there. I'm just gonna take a moment to appreciate that Mo would never turn this kind of work in on a test. Tim, where do you have for that one? It's this one, right?
Yeah.
That's what I thought. Okay.
It's on the board, I think.
It can't be on the board. That's just the left side. What was the other part we did?
Wait,
There should be a coefficient.
wait,
Here.
wait. Wait, but there's two.
Thank you, Sam.
Are you just asking what the other
I just wanted to know what can we fit in our calculator that I just erased to get our length of C. Because I just want to show you that for now, you can approximate it instead of punching this into the law of sine. So we don't want to do that. So, how do we set this one up? We're gonna, I don't like this problem. I don't like doing the whole thing because I wasn't gonna actually do the whole thing. Here I know 102.3. And its opposite is 55.7. But it's a good thing we're gonna do this one. So I'm looking for the sine of A, which is supposedly 49. We can then solve for side A, then do all this again to verify it. This is why it does come into play all 3 parts of these proportions. We could set it up and it would just help us verify it faster. What I'm telling you is with the quick turnaround on this test, you're not doing any of this. It's going to be, just like the review says, we would only be looking for side C with a problem like this. I will make sure you're not doing all of this work on your test. I cannot give you another test. Topic 5 was rough. We're gonna go a little bit easier. I just need to see that you know how to find an angle or a side using the law of sine. So, if you want a +5, finish this problem and verify whether or not this is 49 degrees. Bring it in on Tuesday, staple it to your test. I'll check your work, and if you convince me that you were able to verify it, or not, show that it doesn't work just as well. You know, if you do all this work and you get 42 degrees, we have a problem with our triangles. I agree, go ahead and it's right.
So you said how like if it's not 49, then the triangle could like not close, right?
Correct. Or it could overlap.
Right.
So, let me show you what I mean. Let's say you do all the work and you verify that this is incorrect. It could look like this if it's like 20 degrees. Which, to be fair, I've drawn triangles that look like that for you guys in the past. Or it could be something like this, and then maybe this comes out to be 110 degrees, and we have that. Are those polygons?
No.
Why not?
They don't close.
The bottom one doesn't close.
It overlaps.
vertices aren't touching. Alright.
Oh, what exactly do you mean by verify?
So Sydney said, why don't we just do 180 minus this, like we're in geometry, right? On your last review, that would have messed you up on a couple questions, right? So we're just saying double check it by verifying that A should be 49.
Okay.
And if you verify it and keep verifying it and you keep verifying it and you can convince yourself that it always does work, go for it. But if you find one counter example, then you can't use it that way. The hint being there will be a counter example along the way. It'll look like this guy or that guy. Alright. Now, try to commit all of those standard forms to memory. It's gonna be a little bit of a pain. So we're gonna look at a relationship and some things that we can follow through with each of those. And we're just gonna rewrite it into one form that I think is easier to use. Or not even use this, to memorize. If you're gonna memorize any of this, it's gonna be the one that's in alphabetical order, right? A, B, C, 2B, C, and then A. And that doesn't really work, because it's not reverse alphabetical order. You could do CBA, which is multiplication. Alright. So in purple, first, all of these are basically the same thing. It's just rearranging the relationships between our known side and our possibly unknown angle, or our unknown side and our possibly known angle. All that it's doing here is it's just changing which angles have an unknown and a known. Here it's the same thing. Here either A side is known or angle A is known. The other one is unknown. Here it's B is one is known, one is unknown. Alright, go ahead.
So those two are even.
All of these are the same. It's just we've labeled the triangle in a different way.
Exactly.
So if these are all the same, why memorize all three, right?
Exactly.
Here's the trick. For every one of these, notice if it starts with A, it ends with A. If it starts with B, it ends with B. If it starts with C, it ends with C. One of these is going to be our known, and it's going to be its opposite unknown. So if I don't know C, then I have to know angle C to use the law of cosine. If I don't know angle C, I have to know side C to use the law of cosine. So instead of memorizing all of these, since we always associate x with our unknown, write it as x squared at the beginning and end. And in purple, there's two cases. This is when my side is unknown. I have this as my x. This will be filled in with the angle that is opposite of my unknown side. If I cannot make this happen, I go to the law of sines instead. All right? This is why there are not restrictions, but why you just can't do these if you don't have enough information. So the other case is now I know this side. But I have an unknown angle. But these will always be known sides. You have to know two of the sides to use the law of cosines. So, on the next slide, we'll solve one together, I'll solve one for you. And then we'll have about 25 minutes left where you guys can just work on the review. I'll give you 10 minutes to just work on it, and then I'll ask what question is stopping everybody, and we'll work on that one together. And we'll do that again and again. While you're copying this down, Saturday morning, I put an announcement on Canvas. I'm gonna do a Zoom tutoring for the project, questions 1, 2, and 3. It's like a 2-hour session. I'll be on there just waiting for you guys to join and ask questions. I will help you with it, but I will not set anything up for you. We'll discuss it. We'll talk about what it's asking, how to do certain things. If you're having trouble with like 10% or not, we can do the arithmetic part. But I'm not gonna help you draw, well, I'll help you conceptualize what's happening. You'll be responsible for constructing everything. I will post that link probably tomorrow night for Saturday morning on that. Sydney, go ahead.
Is that apply for the kids doing the extra project too?
We'll have a separate one for you guys, because I don't want to muddle the two. Monday morning, because our test is on Tuesday, I will have Monday morning tutoring pre-calculus only if you want to know. 6:55, I go downstairs. We'll come upstairs at 7:05, and we'll answer any questions from you as a group, like we're about to practice here in a minute. Yes?
If we can't make it in the morning, can we come during lunch?
Yeah, Monday you can come during lunch as well. The only difficulty with lunch is sometimes the calculus students show up too, so then I bounce back and forth. But yeah, you're definitely allowed, or welcome, I should say. Now, does anyone still copy? I think I got 1, 2. Cindy, give me a thumbs up when you're ready and we'll solve one of these. If I'm looking for the angle, if I don't know my angle, like in the blue scenario there, I'm going to use inverse cosine. Anytime I want an angle, I use the inverse function to make sure we have that. Go ahead and take your reviews out now.
Oh, I think we messed up one.
What?
That's the one that fixed the
Who does not have a review?
Halfway in the middle. This is what
I
happens.
had TAs table these. I will no longer have TAs in the future.
Is this what Christian does when I leave? Yeah.
Stick on the middle.
You guys, yeah, look at this, guys. It's like a whole book. Yeah. Alright. We'll do one together before I leave you guys over. I thought I had one on the presentation. So now I'll add one during 6. You guys want to find an angle to cosines, or do you want to find a side? Number 4 though is a lot of science though. I'm hearing number 8.
The hardest one.
Alright, well, in the spirit of what Callie wanted, number 8 makes us find all 3 angles, so you're getting even more bang for your buck here. So let's do number 8, is that okay guys? Unless somebody's absolutely morally terrified of something else on this. Alright, here's the deal. For number 8, I'll do 2 of them and I'll let you guys do the last one. So you can ask questions if you get stuck along the way. So now we're going to use this guy.
Oh, Mr. Fimbul.
Yes, sir.
The stuff that you have written in blue and black, what are those supposed to be? The one up there.
Up here?
Too. Yeah, are they supposed to be for law of cosine? You can't see there for that one. And
This is
then
the law of sine. This is, I do my ratio on the left, and then I one unknown, one known. It's gonna be either an unknown angle and a known side or a known angle. And this is all close. Sorry, I should have read it. That's the closest we'll ever be to a Spanish class. Alright, so. Oh, I didn't do one very, very important thing. Alright. We have side, side, side here, right? Is the law of cosine side, side, side appropriate? Sam, do we use side, side, side for all cosines?
Oh, yeah.
Yes. Good. So, are we going to look at our purple rule? So, if this is the actual formula, we'll call this instance 1, instance 2. Do I have an unknown side here? So I'm not going to use the purple rule, I'm going to go for the blue. So I need my known side to be my x squared. The question becomes, what angle do you guys want to find? Sydney, go ahead. You start with A? All right. Sydney said, let's keep it simple, start with A. So I'm going to rewrite this. Notice here, I want A, so I'm using inverse so I can find what the angle was. So, if I am looking for A, I'm going to make that my X. No, we know we're looking for A. So, I'm not going to do anything with this. I'm going to start filling this in. Remember, these on the outside have to be opposite of each other. So, Rush.
So the angle is unknown, you make the cosine inverse?
Oh, yeah, if you're looking for an angle, go inverse for all functions. So A is opposite of 21, so it's going to be 21 squared. And then since Siraj asked me a question, I'm going to ask him a question. Siraj, once I know that, since I want this angle, I have to use this opposite side, which one of these is Y, which one of these is Z? This might be the trickiest part of it all.
16 would be y and 12 would be z.
Anybody disagree with him? Everyone would do it that way? Everybody would say, would you say Y is 16?
Yeah.
And Z is 12. Everybody would have done that. So if I looked at it, I would say, oh shoot, are we cheating? Josh, what do you see there?
Is it Y 12 and 21 is the
You're both right. So let's look at Y really quick. Does it matter which order I add in? Y plus Z and Z plus Y are the same. Does it matter what order I multiply in? So it doesn't matter. That's all. Just make sure you know it does not matter. So let's do. Oh, now if I put it, I'm gonna make it look like I'm saying one of you was right. What was the first case? This was Y, and this was Z. All right. So I'm gonna have 16 squared. I'm going to have 12 squared. All right. All right, so I always mix up 14 squared and 16 squared every single time. So we're just going to go ahead and do this. What is 21 squared? Let's just start. Now the rest is just simple algebra. What's 21 squared, guys? Good question. 441, right? All right, immediately write it. 16 squared? It is 256. I'll cover this one. And then what is, this is going to be 32. What's 32 times 12? 394?
384.
Perfect, thank you. So you can Kelly?
3 or 32?
Where are we at? This is 32. This is 16 times 2 was 32 times 12. That should be 384.
Oh.
All right. Callie asked me the question, so I'm gonna ask Callie to pick somebody for my next question. What's gonna be my first step here, Eddie, of simplifying this problem? And don't overthink it. What would you do?
Add 256 of 1.4.
Thank you. And guys, where do we get there? That's 300?
400.
Thank you, guys. Keep me on the page. Addie, pick somebody to answer my next question. And I'm gonna tell you before you pick them, this is where most people make their mistakes. So don't pick a friend, or do pick a friend. Just know this is where most people make their mistakes. Sydney, what would you do next to simplify this? We're trying to isolate this. What is your next step? My clue to you is it's color coded. Subtract 400. Now, Amelia's gonna sit back there and say, you told us not to do that in class yesterday. Did I get that part right, since I'm not really doing too hot on the arithmetic today? Can we verify that one for me? Is that what you would get? So, that is the next step. I just wanted somebody in your class to tell me that's the next step. But everybody would just blow with the wind, whichever way I said it. They go, oh yeah, go that way. I could have told them to square root that and they would know it. So I want you guys to, defend your steps. Sydney, you want me to pick somebody for you? All right, I'm gonna go with the chuckles and I'm gonna pick Anirudh. And he even said no. Nice. Anirudh, what's the next step? What are we trying to isolate, sir?
We're trying to isolate A, so I guess, divide negative 384 from
Thank you. Divide both sides by negative 384. That's going to leave me with negative 41 over 384. I'm just moving the negative out front. Is equal to inverse cosine of A. And now we just put that in our calculator. Now I'm going to give everyone a few seconds to get that in. Just give me a thumbs up when you've got an answer for me.
Erase it on there. Erase all this? Yes.
You have 34 that paper. Here.
Sorry. Now, Andre, take over the room. It's yours. Everybody listen to him. I'll stop the camera and then we'll talk about your test and then we'll move on. Andre, if you're explaining for everyone who can't see or if they have quick, you just jumped right in. You skipped a couple steps on it, didn't you?
Oh,
Yeah. Show us your substitutions, how you make the mistakes, do everything. Pretend it's your paycheck.
okay, so for x we're finding the b angle. So the opposite side of b would be 16. So you do 16 squared, or you get 256. And then you plug in the rest of these, so y would be either, which is 12 or 21. 12 squared is 144, 21.
Alright, so what he said so far is he has 16, but he doesn't know angle B. So he did 16 squared and got 256. He made y equal 12, so he got 144, and he's calculating the other one squared with that 21, yeah. So now I have plus 441 minus. You know, that's gonna be a video on it, right? So I'm aiming for the only two. It's not much more. Alright, so now he's added 144 plus 441 and then subtracted that from 256 to get negative 329. And that's left him with negative 504 cosine inverse b.
He's made a mistake. He's made a mistake.
Honorable, go ahead and narrate the rest of this. Explain what he's doing. I'm sure you're closer.
I think he has made a mistake.
Why do you say that?
Yes. There it is. There it is. There it is. Continue, please. As we have the negative 329 over negative 504. That looks like it will cancel out to be 329 over 504. That will be equal to inverse cosine of b. Right there. Right. Yep. We have definitely been promoted to commentators.
You skipped a few steps there.
Andre, you have to put a decimal. You gotta show everything. Show everything. Looks like from here, from this perspective, it looks like he skipped quite a bit of steps.
Yeah.
Alright, did everybody get 49.2 for this?
Yes.
Why don't you reveal the camera for me?
All right.
Hit the red button.
Bye.